In today's class, we'll be looking at partial differentiation. So why do we need partial differentiation? We consider partial differentiation when we have two or more different functions. Now, looking at this question before us, you see that we have z here. What we're supposed to have here, it should be only one function, whether x or y. But here now, we have two different functions here. We have function of x and we have function of y here. So at this point, we consider partial differentiation. First thing, we may differentiate partially with respect to x only without y. We will not touch y. Why? The second one is to differentiate with respect to y and leave x. Okay, so if I'm differentiating partially, there are some things we need to consider. If I'm differentiating partially with x, my major concern is where there is x in the function. I will only focus on where there is x. You can see that there is x here and there's also x here, right? So any place there is no x, like this one now, it will change to 0. Why will it change to 0? Because I'm differentiating partially with respect to x. What about this second one? If I'm differentiating partially with respect to y, so what will happen is that I will only focus on where there's y. Now you see that we have y here, right? And we also have y here. So anywhere there is no y, like this one, like this, anywhere there's no y like this, it will change to 0. So that is just the principle. That is just the principle because we have different functions. So, and to do that, so let's begin by saying solution to that. So for question number 1, we differentiate partially with respect to x, and then we also differentiate partially with respect to y. For question number 1. For question number 2, we differentiate partially with respect to x and also differentiate with respect to y. So that let's begin. Given that our z from question number 1, given that our z is given to be this. Now I want to differentiate with respect to x, which is this first one. Now as I've said that, I will focus on where there is x. What happened to where there is y only? Where there is y only will change to 0. Where there is y only, take note, it will change to 0. And where there is x, I will have to differentiate. I have x here, then I also have another x here, so I will differentiate that two only. Why this last one here will change to 0? Because there is no x at all. Okay, now, and to do that, we say we apply the general method of differentiation. If you are yet to familiar with general method of differentiation or other method of differentiation such as product rule, chain rule is also called function of function, or quotient rule, you can check my descriptions. You will see videos on other method of differentiation. So to differentiate z with respect to x, now as I've said that I will make use of general method of differentiation. So if I use general method of differentiation to differentiate this 4x, I will have what? I will use the power of this x, which is 2, to multiply this 4. Then I will then subtract 1 from the power. That is just it. Very simple. So if I use the power to multiply this 4, I will have what? So I will have 8x, right? You know, if I use 2, which is the power here, to multiply this 4, it will give me 8. Then if I subtract 1 from 2, it will give me 1, right? And x raised to the power of 1 is the same thing as what? X. Take note of that. What about this part? This part, we have x too. X is also here, so I will differentiate it. And how will I go with that? I will go with this. I will go with this by keeping y constant. Now, you may think that, okay, now why is it that this doesn't change to 0? Because there is y here. No, this will not change to 0. Why? Because there is also x. We are differentiating with respect to x because of this x that is here. That is why this will not change to 0. Unlike this part, there is no x at all, so it will change to 0. So this place now I have x, so I will differentiate with respect to x. What will now happen to 3 and y? 3 and y will be constant. 3 and y will be constant. Now, if 3 and y is constant, if I differentiate x, You know, this x here is like raised to power of 1, right? So if I use the 1 to multiply this 3, it will still give me 3, right? And if I subtract 1 from the 1 that is already there before, that will give me 1 minus 1. So I will then have 3x raised to power 0 y. So that x raised to power 0 will give me 1. X raised to power 0 will give me 1. Why 3y still remain the same? I will have 3y times x raised to power what? X raised to power 0. So x raised to power 0, what will that give me? That will give me 1. Because any variable or any number, when we say variable, we mean all those alphabets you normally see in mathematics, such as x, y, z, all those things. So any variable or any number raised to power 0 will give us 1. So that is how we arrive at 1 there. So 1 times 3y will give me 3y. So that is how we arrive at 3y here. Okay, why this one has already changed to 0. So that's the partial derivative of z with respect to x. What about partial derivative of z with respect to y? To do that, the same approach. We'll consider on where there is y, on where there is y. So anywhere there is no y, like this one now, it will automatically change to 0. Now, mind you that we are now dealing with this one now. We are differentiating with respect to partially with respect to y here. So anywhere there is no y, it will change to 0. Like this one, it will change to 0 automatically. So we then focus on where there is y, these two sides. Now, if I'm to differentiate this now, I will have so if I'm to differentiate this, mind you, I'm differentiating with respect to y, right? So I will keep this constant, this 3x constant. You understand? I'll keep this 3x constant. So if I keep this 3x constant, if I differentiate this y, this is like y raised to power of 1, right? So if I use the power to multiply it, this 3x, it will still give me 3x, right? So if I subtract 1 from the power, it will give me 1 minus 1, right? And that will be 0. So I will have y raised to power of 0. And y raised to power of 0 will give me what? 1. Just as I've said that any variable raised to power 0 will give me 1. So 1 times 3x will still give me 3x. So here now I will have 3x here, right? I will have 3x, just as you can see here. I will have 3x. What about this other side? So I will just use the power here, which is 2, to multiply this 5 to give me 10. Then subtract 1 from the power. And that will give me what? 2 minus 1. And 2 minus 1 will give me 1. So y raised to power 1 will give me y. So that is, I will have what? 10y here. So that is for that. Now let's consider the second question now. For the second question, given that our z is equal to open bracket 3x plus 2y close the bracket, open another bracket, 4x minus 5y close the bracket. Now we are differentiating partially with respect to x, Now this is what we do in this case. In this case, you see that this is entirely different from that first one. We make use of an approach like product rule here. Product rule. Which one is product rule? I have prepared video on product rule. Check my playlist. I mean, yeah, you can check my playlist or my description. You see there. So now we solve this by going like this. First of all, I will keep this side constant. Take note. I'm differentiating with respect to y to x. I'm differentiating with respect to x. So I will keep this one constant first. I will differentiate this other side with respect to x only. Then after that, you know, at first I kept this one constant, right? So the second one is I will then keep this one constant. I will differentiate this other side with respect to x. Let me come back again. We are differentiating partially with respect to x, right? So to do that, for this kind, we make use of some product rule here. You know, product rule, if I have this place to be u, let's assume here is u and here is a v, right? So in product rule, you know, I will keep u constant and then differentiate v with respect to x, right? And plus whatever I have plus keeping v constant, then differentiate u with respect to x. That is just it. So to do that, I will keep this one constant. I will differentiate this with respect to x, plus I will then keep this one constant, then differentiate this other one with respect to x. So let's go on by saying, now if I keep this one constant, let me erase it. Now if I keep this one constant, I will have something like this. That is, I will not differentiate it, right? Then if I differentiate this with respect to x, mind you that we are differentiating with respect to x here. Now if I differentiate this with respect to x, I will only focus on where there's x. Now you see that we have x here. So if I differentiate 4x, it will give me 4. That is how we arrive at 4 here. So whatever I have, I will use to multiply it, plus, now this will change to 0. This will change to 0 while differentiating it with respect to x, because there's no x here. Okay, plus now the next one is to, at first I kept this first one constant, right? So the second one is, I will now keep this one constant. I will differentiate this other side with respect to x. So if I keep this one now constant, just as you can see here, I will not differentiate it at all, times, when I differentiate this with respect to x, I have x here, right? So if I differentiate 3x, it will give me 3. That is how we arrive at 3 here. Then this will change to 0 because I'm differentiating with respect to x only. So this is what I will arrive at, and my final answer to that will give me this. Because if I use this 4 to open the brackets, this is what I will have here. And if I use this 3 here to open the bracket here, so this is what I will have here. So that is for partial derivative of z with respect to x. What about partial derivative of z with respect to y? How are we going to go about it? Now, the same approach. I will keep this one constant, then differentiate this side with respect to y. This one does not have y, so it will change to 0, right? So if I keep this one if I differentiate this with respect to y, whatever I have, I will use to multiply it, plus I will then keep this. At first I kept this side constant, right? This side constant, but this time now I will then keep this side constant, then differentiate this with respect to y. And while differentiating with respect to y here, I will only differentiate this side. What will happen to this other side here? It will change to 0. This will change to 0. Okay, what are we going to have then? We have something like this. I said we keep this one constant, differentiate this with respect to what? With respect to y. That is, I will only differentiate this side. Mind you that it is this side that has this minus. So if I differentiate minus 5y, it will give me minus 5. So that is how we arrive at minus 5 here. And we kept this one constant, right? So you can see it here. Then what about the second side? For the second side, I will keep this one constant. So just as you can see here, then differentiate this with respect to y. I will differentiate this with respect to y. So this will change to 0 because there's no y here. Okay, so if I keep this one constant, you have already seen it here, right? So if I then differentiate this to plus 2y, or you can say 2y, so it will give me 2, just as you can see here. Okay, so what will I do next is I will use this minus 5 to open bracket here to multiply this, and then I will use this to multiply it. So what will be our final answer? Now, what you do for me is finish the calculation, then pick the correct answer. But mind you, be careful of the answer. All the answers looks the same, they appear the same, but be careful of the sign. Mind you that if you use this minus 5 to multiply this, it will affect it. Okay, take note of that. So be careful of the sign. Choose the correct answer and drop it on the comments below. If it is option A that is the correct answer, say the correct answer is option A. Or if it is option B, say B. If it is C, say C or D. Choose the correct answer, drop it in the comments. And don't forget to like this video. Don't forget to share this video. Don't forget to comment. Don't forget to subscribe. See you in my next video. Thank you.